Earth's launch ramps are about to get a radical upgrade, with Maglev launch systems replacing brute force rockets at liftoff. Instead of roaring chemical engines all the way up, these systems use powerful magnetic fields to levitate and accelerate spacecraft along a track. Think of it as a hyper-advanced maglev train that doesn't stop at a station, but keeps going until it nearly reaches orbital speed. In one design, a 100-kilometer-long evacuated tunnel sits at high altitude and uses magnetic forces to push cargo vehicles to over 8 kilometers per second. The electric energy needed to reach that speed costs a fraction of a dollar per kilogram, making the launch itself far cheaper than today's rockets. At the tunnel exit, the vehicle bursts through a special MHD window that keeps outside air from flooding the vacuum, but lets the craft fly out. Because the tunnel is already at several kilometers of altitude, the craft enters a region where air is thin and drag is much lower. A small onboard rocket engine then finishes the job, nudging the vehicle into a stable low Earth orbit. Engineers call this the Gen 1 concept, a high-throughput robotic cargo system that could launch thousands of tons of payload every year. A more ambitious Gen 2 version imagines a fully maglev levitated launch tube high above the atmosphere, sized to carry large numbers of passengers. In that version, the entire structure floats on superconducting magnets supported by magnetic fields instead of steel towers and concrete. NASA's earlier magnetic launch assist studies show how even a short ground-level maglev track can give rockets a powerful boost before main ignition. By replacing the first stage burn with electromagnetic acceleration, rockets need far less fuel and can carry more payload instead.
In that version, the entire structure floats on superconducting magnets supported by magnetic fields instead of steel towers and concrete. NASA's earlier magnetic launch assist studies show how even a short ground-level maglev track can give rockets a powerful boost before main ignition. By replacing the first stage burn with electromagnetic acceleration, rockets need far less fuel and can carry more payload instead. Aerodynamic stability and thermal loads remain key challenges, especially when vehicles transition from the tunnel to open air. Chinese companies are now pushing maglev-assisted launch pads that can accelerate rockets to supersonic speeds before the main engines light up. On such a pad, rockets might hit Mach 1 or more while still magnetically guided, then coast upward like a projectile with a rocket kick. The goal is to double payload capacity and slash operating costs, turning space launches into a near-routine operation like a busy airport runway.